This is part 4 of the Mosaic tutorial using data courtesy of Stefan Lenz of the Milky Way and Rho Ophiuchi. In this part we will focus on performing gradient light pollution correction on the data and background calibration on the data with the purpose of making a flat and grey sky background. Before I'll start, both light pollution correction and background calibration are performed with the Remove Light Pollution tool. So the Remove Light Pollution tool will save your data with background calibration as well. So you don't need to run the calibrate background tool afterwards. First, you will need to place area select boxes on parts of the image where there is no nebulosity or galaxy. So that means you have to place the area select boxes on parts of the image where there are only stars or no stars at all. There shouldn't be any other signal. The area select boxes may contain a lot of stars. Up will disregard the stars in the calculations, so the stars will not affect the outcome of the correction model calculations. So if you place an area select box and there are a lot of stars there, don't worry about it. Probably in my own experience, the main key in getting a good correction is to create the correction model step by step. Focus on just part of the image and extend that part. So get one part of the image right and slowly increase the size of that area by placing new area select boxes at each step. Placing the area select boxes at the right place does take some practice and experience. The model flexibility can be adjusted. The model that looks correct with the lowest flexibility setting tends to be the best model, since that model will be less vulnerable to having placed some of the area select boxes at the wrong place. Another way of saying that or putting that is by saying the stiffness of the least flexible model allows for not placing the area select boxes at exactly the right place. So let's start the Remove Light Pollution tool now to show you how I would correct the entire mosaic. This is the entire mosaic after having rotated it by 92 degrees counterclockwise, as shown in the previous part of this tutorial. I will click on Remove Light Pollution tool. I want to apply that on the image in the image viewer. So what I will be doing is I will be performing the light pollution correction, the gradient correction on the mosaic on its original scale. So this is a very big field of view. So a lot of data needs to be corrected. First, when the tool starts, you will notice that the colors have changed. The tool initially starts by performing background neutralization on the data. So it is using the histogram of the data to initially create a neutral sky background. But because there is not information available yet which parts of the image actually contain only sky background, this correction is not correct. That is always the problem with general background neutralization. It's an histogram operation and it's not correct. It's only a first approach. Another valuable tip in performing good light pollution correction is that you want to see the data stretched very strongly, oversaturated, because that will help you in seeing all the problems that we have in the data with respect to gradients and light pollution. As I indicated before, this data is still linear. So if I set the preview filter, the DDP preview filter, to no stretch data as is, you will see the linear data. There it is. As you can see, it's really dark. This is the unstretched linear data of the mosaic. So the linear aspect of the data is still preserved. We have been only looking at the data in previews. So what I want to do is stretch with the most extreme stretch of the presets, which is the bottom one. That will enable me to see very clearly how variations in illumination across the field of view are, and by enabling saturation a lot, it will be even easier to see everything, all the deviations. So I set the saturation to 30. And what we also want to do is adjust the saturation threshold value. The saturation threshold value is a protection mechanism to prevent saturating the sky background, so that will protect injecting chromatic noise in the sky background. If you set it at 0.25, it means that the first 25% of the whole data range is protected. If I would set it at 0, nothing is protected. So in this case, I want to set it to 0. I don't want to see the data with protection. I want to see all flaws of the data, all deviations. Now let's start with placing the first area select boxes. Don't start with placing area select boxes all over the image to start with. Just start with a couple. At least 5 are needed to get started. And our goal is to first get a part of the image correct. So I'm going to place the first area select box over there. I think we can place one over here. Then probably another one over here. While working in the tool, you can zoom in and zoom out with the left and right mouse button. As you can see, we have very high resolution. I'm going to place one of the area select boxes over here. So if you're working on a very big field of view, zooming in and zooming out can actually help a lot with placing the boxes at the correct place and the correct size. I'm going to place a box over here, the box over here. So as you can see, we have nebulosity over here. You shouldn't place a box on that the brown dust, as you can see. Place the boxes at parts where you only see stars. So probably this is a good spot. Okay, we have placed 5 boxes to start with. Let's do a first calculate. This will now create a model based on these 5 area select boxes. So, as you can see, a big correction has already been done on the top right side of the image, basically. So, we are going to focus now on this area to get this right, and then we will extend the model to this area and to the left side. That is the approach that I'm going to take. Let's place another couple of boxes. I'm zooming in again. I think we can place one over here. I think we can place one over here and one over here. So if you place a box and in the end you don't think it's correct, you can always correct it by undoing the last placed area select box or removing red and yellow boxes. The colors yellow and red indicate if such a box, such an area of the image suits the model. It doesn't mean the area select box is placed incorrectly, but it does mean you need to be a bit careful. The yellow boxes usually are always fine. The red boxes on the other hand, you should be sure that they are correct. If you're not sure, first remove them and try to place another box. Okay, I have placed these two. Maybe I can place one over here. I think we could place one over here. And perhaps one over here in the corner. And let's do another. I'm going to zoom out a little bit to have a look at this area. I disable the scale to fit function, so when the model calculation is complete, I keep seeing this area of the image. I click on calculate to perform a new model calculation, which is almost finished now. Yeah, as you can see, more correction has been applied. Let's zoom out a little bit. Okay, let's place more boxes now. This one is showing red, but if I look at the data over there, I still think the box might still be okay. I leave it for now. What we can do, however, is I'm seeing faint nebulosity over here in these parts, but not over here. I'm going to place a box over here. This box will then further help in correcting this area of the image. Since there are boxes here as well, this box now will only affect this area and will have less effect on the areas over there. That's basically how these models for correction work. As you can see, this box seems correct. There is some bluish nebulosity still over here. I think we might be able to place a box over here as well. In addition, that should stabilize the model over here. Let's go to this part. Let us have a look. I think in this area we could place a small box. And over here should be possible. Maybe we can go to this part, focus over here. Well, let's have a look. I think this could be a fine spot. Okay, let's zoom out a little bit and perform another model calculation. So as you can see, I'm creating the model step by step. If you start placing boxes all over the image to start with, chances are you will end up with a bad correction and you will not know which boxes have been placed at a bad place. So just by placing boxes, a couple, performing a calculation, and then continuing from that really helps in getting a better correction. Just do it step by step. Well, as you can see, quite a bit has changed. So before continuing, let's explain a bit more about background neutralization and background calibration. As I explained, the tool starts by loading the data with background neutralization. That initially changed the colors, as you could see at the start of this part of the tutorial. We have now placed 15 area select boxes, and these boxes, these areas of the image, are used to create the correction model. They are used as well to immediately perform background calibration as well, because I am telling Astro Pixel Processor that our selection boxes, our area select boxes, that those areas of the image represent sky background. So the intensity values in those areas are used to perform background calibration as well. So the data that you are seeing after having clicked on calculate is background calibrated data as well. And keep in mind, the data is still linear. We are only working with a stretch preview with the preview filter. Okay. Well, then another remark. Before this calculation step, we had a red area select box over here. Before starting this calculation, I added a box over here and a box over here. And now, with the new calculation, this box does seem correct. So I'm keeping this. And I think the correction in this area of the image is now okay. I don't think we need to add more boxes over here. This looks good. Before running calculate, the last step, I place this box. This is red. Well, I think that this box could be off. It doesn't look like it. Maybe there is a little bit of nebulosity over here. What we should do now is place another box, or perhaps remove this one. In this case, I'm going to remove this one. We only have one area, only one red area select box. So I'm going to remove red. It's gone. And I'm going to place another box over here. I'm going to place one in this part. I think that might be a little bit better. As you can see, there is faint brownish nebulosity in this area, and that box that was here might have been affected slightly. Okay, I'm interested now to further expand our model on this part of the image. So I need to look for areas where I can place new boxes over here. And as you can see, placing one over here is rather difficult at the moment. So we should place new boxes at the border of the region that looks correct at the moment. I think in this area we can place another box. This area. That should be fine. Perhaps a little bit lower as well. In this region somewhere. I'm going to try to place one over here. Okay. Zoom out a little bit and let's run another calculation. Calculation is almost finished now. There it is. Well, as you can see, the new box in this area is now yellow. I think that's fine. The two new boxes that I placed are red now. They might be off. Let's have a closer look. Well, I think this could be off. From this one I'm not quite sure yet. Let's remove both and place new boxes. I think this really should be fine. Let's go again to that area. I think this part should be fine as well. Maybe we can start a little bit expanding the model over here. At the bottom part as well. Let's have a look. Now, if you look closely, you see nebulosity extending to here from this part. I think if we place one over here, we're fine. I think we can place one safely over here. Okay. Run another calculate. Well, let's wait for the model to be shown, the new correction to be shown. There it is. Okay. Well, this new area select box over here is yellow. This one is even green. So I think these are fine. Maybe this one is still off. Let's leave it for now, but place another one over here as well, because I don't think there is nebulosity there. I really think this should be fine. and this maybe not. I'm confident about this one, not about that one. Still remove that one. Okay, let's focus on extending the model further to the left. I think we should be able to place one over there, in this area. That should really be fine. Let's have a look at that area. I'm going to take a bit of a guess to help seeing this region of the image. So in the next correction model, the next model run, it will show more easily what's happening here. So I'm going to place just one box in this part of the area. Well, I think we should be able to place one. I'm going to place another one over here. So there's the new model. As you can see, quite a bit changed again. I'm seeing a bit more over here now, which was my intention. These two, yeah, they might be wrong. It's still hard to say. I do think we have a little bit more information on this part of the image. I think we should be able to place a box over here. And there might be place for a box over here. Let's run the model again. Well, I'm getting to see a lot better now what's happening over here. As you can see, these are no longer red. They seem fine. These boxes, as you might have noticed already, they seem to be at the border of the correction model, right? I have boxes in this area. Boxes, if you have strong corrections to do, boxes that are at the borders of the model tend to be false negatives sometimes, which could be the case over here as well. We can further improve our model. In this area things have become much clearer now. This is a good spot. Should stabilize the model further. Perhaps this little spot is nice as well. As you can see as well, I'm placing the boxes. I'm trying to place the boxes in a uniform fashion. I don't want to cluster the boxes, really. Try to place them uniformly over the entire field of view. That usually helps quite a bit with getting a better correction. It's interesting to notice that this area is becoming more clear as well as we are correcting this part. So apparently the model has influence now here as well. It's interesting to see. So the model is bending, and the way it's bent still has effect over here. We can start by finding out a little bit more about this area. As you can see, there is nebulosity in this region, but there might not be over here. So I'm going to try a box over here and see what happens. Maybe another one in this area as well. And let's return now to this side. I think these might be correct. It's still a bit hard to see. I think we can place a box over here. That should clear this part a little bit up. Maybe somewhere over here as well. I think somewhere over here might be okay. We can possibly look over here. This seems to be only sky background. Okay, let's do another model calculation. So here it comes, the new calculation. Well, as you can see, this region is becoming much clearer now, and these two boxes might be okay if we look at this. Perhaps we need to do a correction over here in this part. We used to have a box there, but that was red. It was gone again. Well, I do think we can place one in this area. I think we can place one over there. As you can see, the data is just full of stars. It's amazing. It's due to the wide field nature of the data, and because we are looking at very dense star fields along the Milky Way. Let's have a look over here as well in detail. I think we can place one over here as well. It should stabilize this region. Yeah, I think one over here could be possible as well. I do see some nebulosity over here. Maybe over here as well. I can place a small box. Let's have another look at here. By expanding this region, we should be able to place one in this area. I think this is fine. This should be fine. Perhaps this area. Might place one over here. And I might think this could be something. Let's wait for it to finish. It's nearly there. There it is. Well, look at that. I think this part, this whole part is looking very good now. These are fine. This looks good. This looks good. This one might be off, and these two might be off as well. Let's remove the reds. I'm going to focus here. The other one was placed over here, and it seems here is some nebulosity as well. This seems okay, that part. and perhaps this part as well. Let's return to this area. I think this is okay. Maybe this area is just too full of weak nebulosity. Perhaps only over here there's room. Performing another calculation. Well, let's see what is happening now with the latest additions to the model. Okay, this now seems fine. We got a red one over here. It doesn't seem to fit the model. Let's have a look. Yeah, that might be right. It might be nebulosity over here. I think we should remove this one and place it over here. And let's have a look at the other two red ones. Yeah, might just be full. This region might just be full of weak nebulosity. I'm going to remove the reds again. Let's place a new one in this area over here. I'm going to place two and leave it at that. I think this region already looks very good, but by placing still a box over here helps stabilizing the model in that region of the image. Well, let's go one more look over here as well. Yeah, I think we should place one box over here and leave it at that. I don't think we can place one in this area. Doesn't seem really possible. Perhaps we can correct this part. As you can see over here, there are some minor flaws with the mosaic. The mosaic seems blending. You can see it over here. I'm not too concerned about this because in the end that part will be cropped off, so I was already fine with that. So these borders aren't a real concern. But what we can do, we can use the remove light pollution tool to still correct this a bit better. So what I will do, I will place some more boxes to see if I can improve it a little bit more. Well, let's have a look. Well, let's see what happens in this region now. Well, as you can see, it has changed a bit. I'm getting some red boxes over here, but I do think they are quite okay still. So I will not touch these for the moment. I'm going to focus a little bit more on getting this correct. There's some reddish glow, which is artificial, I think, over here. I'm placing a couple of boxes just to help correct this area a bit more. I think this should help. This should further improve this part. As I explained earlier, boxes tend to help with correction in the area that they are placed. Boxes that surround a box that you place will protect that box from influencing other parts. So this box has influence on this area, but it won't really have influence on this part. It shouldn't have a lot of influence. So by putting some boxes in a small area and surrounding boxes on that area, you can just focus on getting that area correct. And these boxes at the borders will still protect the model on that side. So let's have a look at how this looks. Well, as you can see, this area does look pretty good now. Reddish glow, which was apparent here, is almost gone. Since this will be cropped off in the end, I think this is fine for now. The area looks good, especially if we look at it from this perspective. Let's have a look at these red boxes over here. Yeah, this could be wrong, but it's hard to tell at the moment. Now, what about these? Now, we can always try to remove the reds and place new boxes in these parts. I think that one. I move red and I'm going to place new boxes. I think this, well, what would be a good spot? Since we have saturated so much and haven't protected the background with the saturate threshold filter, you see chromatic noise in the background, right? But that still helps with placing our boxes. I think this area should be fine. Going to place a box over here. I'm going to go back there. I think that should be fine. Well, let's go over here because we had boxes over here. That really should be fine. Maybe we can place one over there as well. Should be possible. Let's place a new one in this area. Place one over here. So these are small boxes, but by zooming in we can place them rather carefully. This one looks fine still. Okay, here it comes, the new model. a new correction. Well, yeah, okay, we have some more reds. We might be able to have a look later at these. I still think this area looks rather well at the moment. I'm confident this one is okay. It's at the border of my model. I keep it for now. This area looks really well. So we now come to the part that we need to correct the left side of the image. To correct the left side of the image, we need to start in this case by placing a couple of boxes in the corner over here, I think. Let me zoom in so I can know a little bit better what I'm doing. I'm going to place one over here and probably one over here. And we just need to have a look at what happens now, because it's quite a distance from these boxes. Oh, that's the wrong one. From these boxes to here. So by placing new boxes over here, the model will change in this entire region. So we need to have a look at what happens. Well, as you can see, by placing the boxes over here, it has quite an influence on this entire area. As I mentioned, the model is being changed in this entire region now. These boxes might be okay. Maybe I should place one a little bit more in the corner over here, and the other one over here. But first let's remove those two. I'm going to place this one, and try again. So let's have a look again what happens. Yeah, I think it's a bit better. That looks rather good, I think. As you can see, in the Milky Way there are dark sky background areas as well, which you can exploit to correct our model, to further improve our model, I should say. If you look at this area, for instance, it might be okay to place a box over here, a small one. We just need to test some areas to see if that helps in improving the model. Perhaps in this area we have a nice spot. Perhaps over here. Well, this might be okay. Perhaps a bit here on at the bottom. We can add one or two. I'm going to try placing one over here. And let's do a new model run to see how this will affect this area. By having placed new boxes over here, with these and these boxes already there, the model over here should be adjusted. Here it comes, the result. Well, as you can see, this has quite a significant impact on this area. The question is, was it correct? I'm not sure. I'm going to remove all three. and place some new boxes on places where I think it's best suited. Because a correction has been made here, the area is a bit more visible as well, so that does help. You can just try placing boxes to have the regions show up more clearly. So in this area, I feel we could place one over here. You might even be able to place one over here. Well, let's be careful. Perhaps over here. I'm going to place one over here. Okay. Perhaps in this region we can place one that should help in correcting this bottom part. As you can see, there is nebulosity. I think this one is fine. I think this might be okay. Okay, I zoom out a little bit and run calculate again. I'm interested to first get this right before getting that part right. Let's see what the impact will be now on this area. Yeah, it's a bit different, as you can see. Well, this box, let's have a look. Well, we could probably move it, undo the last one. I'm going to place it over here. Maybe we can even add one over here. Perhaps over here. This one does look okay. Maybe another one over here. Let's focus a bit higher. In this area, I think we should be able to place one over here. In this dark area. Here it comes again. Okay. We're getting there slowly but surely. As you can see, it's an elaborate process. If you have such a large field of view with so much detail, so much signal, it's a bit complicated, but if you are patient and work step by step, you can achieve very good corrections. The main thing is focus on adjusting parts of the image step by step, and then extending, increasing the model area by keeping everything in the correction area as good as possible. Just do it step by step. Okay, I have skipped to the end of my light pollution gradient correction on the entire mosaic. This is how it looks in the end. I skipped the correction of this area. The same applies, the same suggestions that I made. for correcting this part and this part. Take it step by step, and you will get a very good correction in the end. Let's zoom in a little bit so we can have a look at how the boxes are placed. So as you can see, the boxes are placed rather uniformly over sky areas that mostly contain only stars or nothing at all. Some boxes show up red. Well, they do seem okay. Don't mind that. You could try to replace them with other boxes, but I'm confident this is quite okay. Let's go to the bottom area. As you can see, a lot of nebulosity, but the boxes are placed rather well, as we can see. We have our little boxes over here. They do help. The size of an area select box has no real influence, but I must point out that if you use a bigger area select box, the statistics, the calculations for the data on that box will be more robust, more reliable. But in most cases, even a small box already has enough information to use for good calculations. So don't worry about very small boxes. If you can place a bigger box, by all means try to do that. That will only help. Well, as you can see, the boxes are placed on areas with only stars and background sky. And you can also see that having stars in the boxes, like in this one, is no problem at all for Astro Pixel Processor. Well, let's have a look at this corner. Yeah, it does look good. Let's look at the Milky Way, the dark areas. Does look good to me. It's excellent data from Stefan, as you can all see. This does look good, As you can see, I've placed the boxes in the dark areas. And as you can see, it's also one over here that helps. And even this top left corner of the entire mosaic, this was a bit complicated, but after several calculations and replacing the boxes in this area, the correction in the end does look rather good. So if you're not happy with an area, just remove those boxes, the boxes that you placed last, by doing undo area select box. That basically is your step back in the process. If you have calculated once and you place some boxes, the new calculate isn't dependent on previous calculations. Each time you press calculate, a model is made based on all area select boxes that are currently present. So if you move several boxes and add a few more, it's an entirely new calculation. So keep that in mind. Each calculation is a complete model calculation. Okay, I am happy with this for our light pollution gradient correction. Let's save it by clicking on OK and save. We will save it again as a FITS file, and remember, the data that we are saving is the linear data still. We are not saving the stretch data, we are saving the linear data. Remember, the preview filter over here is showing the linear data stretched. So that means that the model calculation and the model itself are performed on the linear data as well. And like I indicated before, we are saving the data with the correction model applied, and this data is already background calibrated now. You can see this from LPC CBG, light pollution corrected, calibrate background. Now, to conclude this part of the Mosaic tutorial, I will show you the difference between the not corrected and light pollution corrected result. I have put this in an image so you can directly see the differences. The top image is the Mosaic after the Mosaic integration, and the bottom one is the light pollution gradient corrected data. As you can see, several parts of the image have been improved considerably. Since this data is now also background calibrated, we can load this into the star color calibration tool for the next step of our tutorial.